Good afternoon. Welcome to the Ignite Hub. We're glad to have guests here in person, and thank you to our guests that are joining us online. It's March. It's our Future of Tech Lunch and Learn, and happy spring. Today is the first day of the equinox. So we're looking forward to warmer weather, longer days as well. So thank you for choosing to be here today and spend some time with us. AI is one of our most popular topics here at the Ignite Hub. So what we try to do here is bring a variety of perspectives of looking at AI in different industries and different ways of how can we use it as a tool. It's here, so how can we not be afraid of it and use it in ways that empower us to do whatever we're trying to accomplish. So for today's guest, we have Dr. Feldman. So I'm going to do a quick introduction and then I'm going to hand it over so we can learn more. So Dr. Feldman is the artificial intelligence / machine learning futurist for ASRC Federal and an adjunct research assistant professor of information systems at the University of Maryland, Baltimore County. His background includes motion picture production, photography, and even the unique opportunity of recording audio from a line of M1 tanks on a firing line. He has held a beating heart in his hand. Phil is a prolific writer and speaker, having authored the book Stampede Theory, Human Nature, Technology, and Runaway Social Realities, and presented at numerous conferences on topics such as AI, ethics, and social media. He has also been featured in media outlets like New Scientist. Beyond his professional achievements, Phil is an avid cyclist who has explored 3 continents and 10 countries on his bike, including an accidental ride through Luxembourg. So without further ado, let's welcome Dr. Phil Feldman.
Did I turn it on? I think I turned it on. All right. Well, thanks for having me. As they say, I'm the AI ML futurist for ASRC Federal, which is the cool job title, and I will never have a better one. But it means that I've been working with AI systems for a long, long time, back before they actually worked. And now that they do work, they work in weird ways, and we tend to use them in the easiest possible way, and we want to write with intention. We don't want to have just enter a prompt, get the response back. And the reason for this is there's this thing called slop. Slop is like the definition in the upper left. It's just low quality media generated by these systems. And you've put in a minimum prompt, you get a minimum response. And everybody does this. And this is why we are just kind of drowning in a fire hose of crappy writing. It's, grammatical, but it's terrible. And nobody really knows how to use it. Joe Rogan yesterday was like, let's ask Grok who killed JFK. This is a terrible idea, and never do that. And we will talk about why. All right, next slide. All right, so before we get started, you don't have to use generative AI. It doesn't provide facts or data very well unless you modify it. Its output's often wrong. It can produce absolute nonsense. It's kind of fun to try to get it that way. It can't be held to account that your name is on the tin, so you're the one that's accountable. It can be immoral to use. When you're trying to decide a case, don't use AI. Overuse of AI can make you dumb. And when you have all those pieces and you're fact checking and you're making sure the writing is good and you're getting rid of the dells, you may spend more time fixing an AI response than you would be by writing it yourself. So you don't have to use AI. So let's start from there. All right, next slide. All right, so this is how computers used to generate text. This is a thing that Google Scholar sent me. They send me papers, and this means it passed their threshold test for whether or not it was AI. And it's just a bunch of random words that are strung together, kind of like Mad Lib. You've got nouns, verbs, adverbs, you have some rules, and then you use a random number generator, and it produces sciencey stuff. Now, what I want you to really pay attention to is that red square on the right. GPT-0, state-of-the-art AI detector, says that that is 100% human. Now, we know better, but the tests that detect for this, that use AI, don't. So, bear that in mind. All right, so now we go to the present. Next slide. And we're going to have a really quick course on how large language models work. They work through this idea of embedding. What you do is you take a sequence of words, some small sequence of words. Once upon a time there was, and you have the system predict what the next word would be. In a neural network, you have the input layer, you have this middle layer, and you have the output word. And the values that that middle layer produces is the embedding. Turns out that those are really, really useful things. You can position them in space. So we'll be talking a lot about Moby Dick because it's a thing that I use a lot in my research. The space of things that have to do with Moby Dick are in an area around Moby Dick. And you can do math with this. And the most famous piece of math with embedding spaces is this idea that the embedding for king minus the embedding for man plus the embedding for woman is roughly equal to queen. And the color bars that you see down there are values that are for each embedding. So you can see that king has a certain representation, and that red bar is common through everything, and that blue bar is common through everything. Man has a slightly different one, so you subtract that, you add woman, and you can see that the value of king minus man plus woman and the value of queen line up a lot. And it's not that they're exactly equal. All of this stuff is based on distance in space, and it's all about approximate answers. And we'll get to that in, I think, the next slide. All right, so this is how we train a large language model. And here we have the beginning of Moby Dick. Call me Ishmael, some years ago, never mind how long precisely, having little or no money in my purse is the next word. And what you want to do is you want to train a model, and you take all the writing on the internet, and you train it so that it predicts the next word, and then it predicts the next word, and then it predicts the next word. And if it doesn't predict the next word, which is just an embedding, it's like the 6.674.140, you're just trying to get that value. It back propagates through the model and forward propagates until it gets to purse. That's how you train a model. Millions of dollars in electricity to do that. All right, so next line. This is how you infer. So same thing, we're going to start with the first line of Moby Dick. We're going to feed it through the model. It's going to produce this number, and then it's going to look for the closest match. And in this case, the closest match is purse. Now, one of the things that language models do is they don't always take the closest match, because then there's no variety in the generation. So it might take the third, handbag, or pouch, or pocketbook. And once it's done that, then it starts to go off on a little separate path. And now you're not producing Moby Dick. It's no longer accurate. It's hallucinating. That's what hallucinations are. Just random choices on which is the next most likely thing to choose. Follow that path. So it's built in. It's always going to be there. All right, next slide. This doesn't happen just in one layer. It happens in a lot of layers. These are giant, giant models. And each layer, so this is a 10-layer language model. And layer 1 takes one part of the text. Layer 2 takes another part of the text. Layer 3, layer 4. It's going to take all that information, all those values, to just determine the next token. All right, next slide. So what I want to do with this explanation is to talk about why AI is not like talking to another person. It is talking to a statistical machine that happens to sound a lot like a person. Is it a plagiarism machine? A lot of people talk about it being a plagiarism machine. It kind of is. That training data that's in it reflects its behavior, or its behavior reflects the training data. But I think it's more like, if you really want to have a metaphor, looking at a root from a seed. The root depends on what kind of seed it is, the soil that it's in. And if you take a look at those 4 seeds, each one of them is the same seed, but they're hitting slightly different conditions in the soil. It's like that change in which token to choose as it's going through purse or handbag. And that makes big changes later on. But it's the same seed, just slightly different conditions lead to a different thing. So think about it that way. It's more like interacting with those sorts of systems than it is like interacting with an intelligent machine. All right, next line. All right, so we used to have only one seed, and now we have a lot. We have ChatGPT, what everybody has used. We have Google's Gemini. Anthropic is a very interesting and popular model that's coming up these days. And you can also go to other countries. LeChat is Mistral, that's a French company. DeepSeek is Chinese. And then you have just the others, Meta, X, Copilot. You go to various places like the Hugging Face Hub, you can download literally hundreds of models. These all have their different personalities. They all have their different characteristics. They all have different depth. They all have different costs. Some of them are free. Some of them cost quite a bit of money. And they all give different responses and different capabilities. So let's keep on going. One of the really important things to realize is that every model is biased. They are trained on their training data. The data itself is biased. And they can be poisoned, which is a way of enhancing a particular bias from an adversary. Now, I use this is really the only time I'm going to talk about image generation, but we have on the upper left, we have Midjourney, and on the lower right, we have Copilot. If you look at the upper left, the prompt is man and woman. That's it. But if you look at the images, these are all young, except for the weird painting, white people. And if you look at the bottom one, they're young, and also with this weird AI, too colorful, strong vanishing point, very centered thing, that's another bias. So you have to be aware that these biases always exist and you can never get rid of all of them. Producing English text is a bias, right? Models could be biased to producing Chinese text. And then you have to be aware of data poisoning. So if you happen to look up on or ask your chatbot about Russian operations in, say, Syria, the likelihood that you're going to get a wrong answer is high, just because they have built entire networks of fake information that these models then scrape to pull into train. All right, next slide. All right, so let's talk about the soil and let's talk about a thing called attention. So we know now that text in a language model is just a series of points, right? It's just a series of vectors. And each vector is either more similar or dissimilar to the other vectors. So you're looking at, the entire book of Moby Dick has vector, 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 and you're trying to produce the next prompt or the next token. And it's going to look back across all those and say, well, what's similar to this guy that I'm just trying to generate? And it's going to use those and emphasize those and de-emphasize the ones that it's not similar to. So it needs to look back over what it has to be able to determine what to generate. And a simple short prompt, like man or woman, doesn't have enough information for it to get any hooks in. It's not going to represent your intent. So what you want to do is you want to use longer prompts. And there are bunches of ways of doing that. There's rewriting and expanding the prompt, reasoning models, which generate their own prompts, dialogues, which we all do, explicit content to the prompt, and then additional sources like retrieval augmented generation. And we're going to talk about all that, and you can mix and match these. All right, so next slide. So the first thing we're going to talk about is extending the context. So this is a terrible slide in some respects in that it is too much text, but it gives you kind of the idea. The prompt on the left is write a paper about Moby Dick, and it comes up with this absolutely generic, bland, middle-of-the-road description of Moby Dick. And then the next one is adds more content. Tell me about it as something that deals with indigenous cultures or minority cultures. And now we're starting to go into a direction that's different. It's not at all like the first one. Then we can do other things with hooks, like give it the first line. And that kind of fires it off in the right direction. The line that you do, there's PDFs of this, so you won't have to, there won't be a test. You can kind of get it rolling in the direction you want by giving it the first line of the response that it's supposed to generate. So the more you give it, the better. And what I tend to do when I'm really writing something carefully is I reload the first prompt over and over again. I don't go into a conversation with the model. We'll talk about why in a moment, but this allows better control. And once you have your prompt, then you can keep that prompt, and that becomes something that you can use later. All right, next one. So these are reasoning models. These are brand new and shiny. They kind of working very recently. I gave it the middle prompt, and now it's thinking about what it's going to write. and it's still thinking about what it's going to write. It's basically generating a giant prompt that it's going to reach back into. And now it's writing the paper. And the paper in its entirety is on the right. And it's pretty good. Again, it's now no longer expressing kind of the generic internet intent. It's doing more individualized writing. This is kind of halfway between expressing your intent and the machine kind of trying to figure out what it is that you're trying to say. But it's an interesting system. This is coming along. It's been out for, I don't know, months. Worth trying. Next slide. All right, so this is what we all do. We go and we start talking to ChatGPT, and it gives us a response, and we give the same or a response to that response, and we keep on going. In this case, I was doing stuff about how you can use language models to manipulate people. And there were some things that I just kind of wanted to walk through and see what the model had to see, because I'm asking sort of the internet questions. I want to know what it's thinking. And I steer it in a direction that I want to go. And then finally, at the end, I say, all right, what are the 3 most important things? Make a list. And it's going to look back over that entire discussion. Its attention is going to lock onto certain things. It's going to take what now is a 2,500 word prompt, and it's going to write something that's pretty much in line with what I wanted to do. So you have to be careful, because it can easily generate incorrect information, and the attention will reach back and say, no, the sky is brown and the world is flat. It's actually fun to steer them into those directions. But this is a pretty effective way of getting your intent in, because it comes from the dialogue. But it's a lot of stuff to carry around now. So that's its problem. All right, next slide. All right, so there's this thing called retrieval augmented generation. Does anybody use RAG systems? All right, we'll start from scratch. So in retrieval augmented generation, you don't just have what the model knows, and you don't just have your prompt. You have text that you're going to provide the model. And again, that embedding space, you take your prompt, in this case, working on whaling ship, and it's going to go look through all of Moby Dick to find things that are close to that particular position in the embedding space. And then it's going to add that to the prompt. So answer the question based on the following context. And those are the things that it's pulled out. And then there's the actual prompt. Briefly describe the kind of life a sailor has. So it takes all that. That's the full prompt. And that's a sizable prompt. There's lots of stuff for attention to grab onto. And it comes back, and the life of a sailor on a whaling ship is depicted in the context as arduous, adventurous, and often perilous. And it just kind of does its own thing. But this is a nice way of getting the response that you're after to reflect the content that you are researching, because it's not going to pull from fake sources. You're providing it the sources. So this is a very effective strategy. This is a system that I wrote just to explain how it works, but there are systems now that are in public use. Next slide. These are commercial models. These are 2 of my favorite RAG engines, and I recommend them highly. So the one on the left is perplexity.ai. It does search, returns the search, runs the context based on the search question that you're asking, like briefly summarize Firefly Aerospace. I just chose that because it's something really recent. The model can't know anything about it. It finds its sources. Those are the areas on top. You can see that it has 3 that are listed plus 9 additional. So you can go in, you can check every single one of them. It's all there. And it has items that point back to it, basically that's citing its sources. So that's on the left. On the right is ChatPDF. The simpler system, you upload content to it directly. You want to talk to a particular paper. You want to talk to a particular document. You want to explore that. It goes through that paper, and the same sort of thing. It has sites. It points you back to particular paragraphs in the paper, and you can click on them and see if it in fact is true. And sometimes it's not. I'm going to tell you an interesting story. There is a company that basically translates all the news to English. Anything that has a system that's generating news that a computer can read, it translates to English. And does anybody remember when that Chinese balloon flew over the West Coast? So the translators would not translate it as a balloon. they would always translate it as a hypersonic vehicle or something along those lines, something more technological, because China, in the mind of the language model, was biased towards high-tech Chinese spy system, not a balloon. And it was quite a while before that fed back into the system and became available. So these systems can make mistakes, even though you're giving them the data. They're biased towards doing things. And I'll show you that in the next example. So these are the responses. So this is a particular thing that I was working on for how people polarize into groups. And the thing is that this is an example for a subtle error. And this is based on my book that I just pulled out, so I happen to know everything in this. So in this case, the Tajfel experiment was people were shown a picture that had a bunch of dots on it. And they would say, there are 1,000 dots, there are 500 dots, there are 2,200 dots. And he would just arbitrarily divide these people into groups, regardless of what they said, but he would tell them that they guessed high or low. So when I had the model respond using the prompt that I had, and this is a RAG system, it wrote, depending on whether or not they guessed high or low. That's what everybody would say. That's kind of the normal reasoning. But Tajfel was working against that, right? He was saying regardless of whether or not they guessed high or low. But that switch from depending to regardless changes the entire meaning of the paragraph. So you have to be really, really careful. And the other thing is that these things just don't know how to finish up. Their conclusions, the last three paragraphs or the last three sentences of the conclusions of the language model are always terrible. They're just terrible. So it's usually better to just cut that off, rewrite it, do your own. All right, next line. So if it's like growing something, then the real trick to making these things express your intent is editing or pruning, I guess, because you can take a true tree and you can turn it into a bonsai tree just by basically editing it and presenting the right type of conditions, tying down the branches, clipping the right pieces, and you get a tree that should be 20 feet tall, this big. That's expressing intent in physical form. And so there are these different types of editing. And really, dealing with language models is only the first two. It's developmental editing. What are you trying to do? How are you trying to get it to say it? And then evaluation editing, what areas need more information. You focus on those, you get the model to generate what you want, and then it's kind of up to you. You need to clarify, you need to make sure things are complete, you need to make sure the writing style is consistent. You need to make sure that the grammatical errors are not there. Because one of the things that you do in these things a lot is you edit and all of a sudden there are terrible grammatical errors as you cut and pasted two sentences together that you didn't quite mean to. Happens all the time. So to really express and really get control over your document, you're going to have to do a lot of editing. And this is why they said at the beginning that it can take longer to write with a language model than it can to actually just write on your own. All right, next slide. All right, so we have lots of models. We have many versions of each model. If you can afford it, it's worth kind of test driving them all and paying the monthly fee to get the best models that are available. They tend to be particularly interesting. I'm not a huge fan of the OpenAI models currently, but I love the earlier ones. They have a really nice voice to them. So, paying OpenAI for their playground is, in my case, a worthwhile thing to do. But the model that I use the most for writing that I really like its style is Google's Gemini. So you can state the style. So write in the style of a New Yorker nonfiction article. And tell it to avoid lists because these things love to generate lists. Write in a clean, organic academic style. Write in an easy to understand language for young people. Also, I've had things where I've taken documents that I've written and rewritten it for people who are suffering from early onset dementia. And that becomes a really useful thing. And this is an actual thing that I wrote. This is so in a Hunter S. Thompson style, write a screed about generative AI like ChatGPT that write obviously generated text. Harp on things like the word del and the cloying obsequiousness that when you tell them that they are wrong. Write in the present tense like a blog post. And that generated some great stuff. Again, take a look at the PDF. It'll follow the link. You'll see where it is. It was a lot of fun to write. It's the best fiction, creative writing that I've seen a language model do. Next slide. All right, and sometimes Slop is okay. So when you're writing a complaint email, you really don't want to put that much time into it. Let the model do it. Again, they're writing what people expect to see. You want middle of the road complaints, it'll generate a middle of the road complaint. Also good service. You had somebody at a hotel desk and you don't have time, have the model write it, do a little bit of editing, send it off, you'll make them happy. They're really good at overviews and brainstorming. We've all been told that, and it's true. One thing that is really interesting is to do slop and minimum in different languages. If you enter once upon a time in English, you get a particular story. It's like a Disney fairy tale. If you enter it in Japanese, you get something much more about family honor. If you enter it in Russian, it's depressing. So you can quickly get a sense of a culture if you want to. And again, edit the response. And the reason you want to do that is, for example, a lot of these models have been trained on text that use Markdown. So you get things like star, star, some header, star, star. You don't want that. You want to have the bold text. They want to make lists. You have to make sure that they don't make lists because lists look terrible. And then you need to do a careful read through. And I just got an email not long ago that was signed, best your name. Never let that through. Never let that through. That person is dead to me. All right, next slide. I think this is the last one. Yeah. So I am a technologist. I write code. I build robots. I literally, there's code of mine that's orbiting the Earth. But I am here to say that the humanities are going to matter more than ever. They are the thing to study. These models are trained on human-generated sources. They're compelling because they are trained on human-generated sources. They can speak to us in our own languages. The language is the soil that they grow in, so the better you are with the language, the better it is. The more flexibility you can bring to it, the more creative it'll be. So to use generative AI really effectively, you have to cultivate creative writing. You have to know how to write creativity. You have to know how to do technical writing if you're doing that sort of thing. You better know your literature. One of the reasons that I liked working with Moby Dick for all this work is that there's a particular style and you get to get comfortable with how Melville wrote. And it's fascinating to see how you have to work to get the models to kind of live in that space. Literature, art history, photography, all those things. The stable diffusion models for generating images. If you know photography, you can make these things do tricks. If you know art history, you can make these things do tricks. If you don't know it, then you're going to middle of the road slop. And just to end, AI systems believe that text clouded its approximately processing historic room, its gateway been more than restricted makers on, and actually spent the code, period, is 100% human. And we all know intuitively that that's not true. But the systems don't know humanities. The systems don't know how to read. Study your humanities, be good with these models, write with intention, and that's it. Questions if you have them.
I can start. Okay, is it not? Yes. While I'm speaking.
Oh.
So from here on out, we'll just use this. I just wanted to thank you for breaking that down into really bite-sized pieces for us and using the example of seeds and pruning and how that's something that we can all relate to. So I just wanted to start off and thank you for that, for helping us really understand how we can use this tool. So I'm going to open it up now for questions, which is always the enriching part of our sessions. Of course, our presenters are enriching and the conversation that comes with it. So our guests online, please put your questions in the chat. And it looks like we have somebody here. Yes? Did somebody have their hand up? No? Okay. Okay, we do have a question in the chat. This is from David Vargas. Nice to see you, David. How do you correct errors? It sounds like you can't simply edit something to correct, but to let it, quote, learn the correct answer on its own.
It's a very good question, and it kind of depends on the model. The prompt can learn, right? As you add more information to the prompt, the behavior of subsequent tokens will be more in line with what you want. Now, some systems don't allow you to edit the answer. OpenAI's Playground does. So you can take the answer that's generated by the model, correct it, and then have it continue. But most of the time, I'm talking about taking sort of what I call the LLM draft, putting that into the place where I'm going to edit it and working on it some more there. So I use the model to get me like 80% of the way there, and then I edit and add for the last 20%. I also will often take those same pieces after they've been edited, run them through the model again for grammar checks, all kinds of things. And also I'll find that I'm just missing a paragraph and I'll try to get it to fill in. There used to be a great thing that OpenAI had called the insert. You could say, you could give a paragraph, you could tell it insert and then give the next paragraph and it would try to fill in the gaps. They don't do that anymore. It's really a shame because you would see it when it had insert, it would, and you were not being clear. It would put paragraph after paragraph after paragraph, like, okay, clearly this is terrible. And if it just did like a short paragraph that knitted two paragraphs together, it was great. You can kind of get it to work that way. So teaching these models is really just about expanding the prompt. Give it the right information, cut out the wrong information, and it'll correct.
Sorry about that. We'll get right to you. So David says, seems like a very slow way to get it to learn correct information. I could see adversaries engaging in constant back and forth to poison correct info.
Okay, so we're not training the model, right? So this is the prompt. You can absolutely poison a data set. The Russians are doing that now with pretty much every model that you can interact with. It is slow. Writing well with a language model is not faster than writing. It can be better. I tend to write too densely. So when I feed my prompts into the model, it'll expand it out because I'm too into the thing that I'm working on to be able to go, well, this needs more background. But the model does. It knows how to do that. It is up to you to know whether or not the model's generating the right information. It does not. It's just, predicting the next token and grinding along. But when you adjust the rest of the prompt before it, then it's going to base its next prompt generation, next token generation on that value. Did that answer the question?
I just have a question about getting the the LLM to understand like your tone. Could you provide it content of like previous writings that you have created, like previous papers, so it could kind of understand like how you write your style, and then have use that as like for the output to get in your tone, like your voice?
Good question.
That is a fabulous question. I struggle with this all the time. There are two things that you can do. One, you can have it analyze your writing for tone. What is the style of this thing that I've written? And it'll come back with some words, and you can use that as the prompt and see whether or not it writes things using that style. I've had mixed success with that. I've had a lot of success with finding authors who write similarly to me or who I would like to write. James Glick, for example. If I could write like James Glick, I'd be so happy. So I have it write in a style of James Glick and see what it comes up with. And then it's a little bit of trimming to bring it more in line with my style. You can also give it a sizable amount of text these days and say, maintain the style. But the thing is that the attention also reaches back and grabs other things. So if it's a different kind of document that you're using as your source for style, it's going to start talking about, tax reform or something when you're really trying to write about gardening.
David Vargas says, thank you. We have a question from Samuel. Please clarify the advantages and disadvantages of open and closed source. Also, multimodal models. Thank you.
All right, we'll take open and closed source first. I like open source. You can get models now that are trained completely on open source data. You have to go looking for them a little bit. I think the, oh man, what's his name? The guy, Microsoft, the Allen Institute, they just did a full open source model with full open source training data. So you can go and look through it. The problem is, of course, it's terabytes of data. So how do you really know? That's a problem. The meta stuff is just plundering stuff, right? LibGen, all those models, they just stole stuff. So yes, I'd say it's fundamentally immoral to use Llama. Yeah, I use Llama. Multimodal models. What was the question about multimodal models? Advantages and disadvantages. Honestly, the disadvantage is they're brutal to train. They take a long time. They're finicky, but all that'll get easier over time. I find multimodal models to be amazing. It seems a lot of overkill most of the time when I'm just writing. I like to use smaller models. They are less power to make. They're less power to use. But honestly, multimodal models are every bit as capable as dedicated purpose models. And then you just have to go and find the model you like. I do think, for example, Midjourney is one of the best art producing models, and it is not multimodal, right? It's a stable diffusion straight up model. And you take a look at Copilot, it produces greasy AI images. So dedicated models, I think, have the edge now. I think that that's temporary.
For example, if a student submit homework, this homework is an essay. How to decide that for you, decided that this is essay generated by AI or by human? Thank you.
Good question. Well, this is the core question, right? I think the answer is you can't. I think the answer is that is it good writing or not? If there are, so slop is what we're trying to prevent, not necessarily having students write from scratch. I mean, I'm old enough to remember when I had to do math on paper and they had calculators and they were banned, right? You couldn't even have them in class. Well, now we have language models and writing's going to be different. But I do think that it is possible to use a model to write creatively and well. I urge you to follow the link to the Hunter Thompson thing at the end to see what these things are capable of. It's good writing. I mean, I couldn't believe it when it came out, but it took a day to produce it. Not steady, but on and off, getting an idea, coming back, tweaking it, getting the response. So it doesn't mean that a student that's using language model to write isn't working as hard. They can, but that's the thing, right? It's slop. Slop is always bad. Slop is the D, right? They're now writing stuff that should never be worse than a D. Or, as I've heard, the gentleman's C, right? It's readable. In a way, the bar has been raised for the worst paper that you can submit, right? Now it's slop AI, right? Write a review or a book report on Moby Dick, and it's going to generate what the internet thinks. I think that the best thing to do might be to really just take your prompt, run it through a few language models, get a sense of what the internet thinks. And if they write that, if that's what's handed in, say, this is, the internet came up with this. This is not original thinking on your part. It's a C or a D, depending on how mean you are. Does that answer the question?
Thank you.
Okay, Samuel says, if I'm building an application that needs AI integration to just generate text in a specific context, Which AI solution will you advise me to go with? And do you think creating an agent is a better way to go?
Well, thank you for the question. Agents are fun. Agents have all kinds of tricky secondary issues. They're very new. I would not write an application these days that has one. It's really a cost question and whether or not anything in that is mission critical. I think, I mean, I would use a model that's being served by somebody else because I don't want to deal with all the serving. That's just a pain. There are excellent models that you can get for next to nothing. It depends on the context. And of course you have to worry about people hacking it, right? So I would do the lowest cost, lightest weight system that I could find and see if it was good enough, and then run it past people, test it a lot, have people deliberately try to break it, red team the hell out of it, because people are going to try to get it to generate Nazi propaganda. I mean, it's a given.
So when it comes to Chat GPT, I usually use that for marketing purposes and or even just following up with leads for potential customers or partners. And I notice I can instantly tell it was written by Chat GPT. Like I see certain words. Anytime I see unlock, I'm like, that's Chat GPT. So do you have any recommendations for any more natural sounding I guess, prompts or how to make prompts more natural sounding or any other, I guess, website that would make things sound more natural? Or how can I sort of avoid these certain words that I always see where it's obvious that it's written through Chat GPT or AI?
One of the things you can do is in the prompt, you can say, don't use these words. Gemini actually has a thing where you can give it some additional instruction as opposed to, you are a writer or you are a reviewer or whatever. It's like, don't use these words. So delve is the one that's my clue. Lists, I try to get to avoid. Natural writing styles, in my experience, Claude from Anthropic and the Gemini models are really good. The very first GPT-4 models were really good, because they were poorly guardrailed. And guardrails twist and warp these models in ways that make them write poorly. Spend more on your prompt. Have a prompt that's a couple of paragraphs that describes the writing style, and then rerun it and rerun it and rerun it so that you have the right header for it that you can always use, that specifies sort of what your voice is. And you'll narrow it down over time and you'll have your list of words to avoid. They will always be in their writing because there's this thing called perplexity, which is the amount of surprise from token to token to token. And language models have less perplexity than human beings. But that text has tremendously more perplexity. It's just random, right? So the detectors that we ran the stuff through, you see this distribution, this bell curve of text from language models. And then slightly overlapping, but with a little bit more perplexity is human beings. And then way out here is that. So you can't kind of get away from that. You're always going to have them be more comfortable. It's the difference between a good steak and a meatloaf. Language models produce meatloaf. You're never going to get better than really, really good meatloaf out of them. If you want to have something that really sparkles, you're going to have to write it.
Okay, I'll be right there. Just to jump back to Samuel, he had a follow-up question about the integrating AI. He wanted to know if you could suggest a few different AI solutions. I can reread the question if you need me to.
It's the special purpose or dedicated text generation, right? Because they have so many models and the API is really straightforward, I would recommend using OpenAI system. I would recommend, I'm blanking on LangChain, use LangChain. You can then swap out the models. It's really easy. Prototype it, with the minimum amount of code to make it work. But I mean, getting one of these things up and running is so easy, especially with LangChain. LangChain makes everything so simple, and it runs in JavaScript and runs in Python. I think it runs in something else. It has a problem in that it's becoming all things to all people, so it's getting kind of big and bloaty. But even the OpenAI API is trivial. I mean, they have a quick start guide that's just fabulous, and you can be up and running with completion, with chatbots, with agents in hours. So I hope that answers the question.
Yeah, a cost question. So a couple of weeks ago, there was an article that talked about how large language models are becoming cheaper and cheaper to build. I'm trying to understand, as you say, it takes years to load data into the model and train it. What's driving the cheaper and cheaper comment?
That's a good one.
It's a very good question. What's driving the cost is because it's expensive, and the companies hate spending money on it. So data is basically free. There are data sets, there's the pile, there's all kinds of different things that you can use. Mostly getting the rights for data is the hardest thing. So that's why they get stolen. And when you're OpenAI, no one cares. The other parts are just the development of hardware, the tensor processing units, the ability to manage the data exchange across the service buses. But also, and this is really important, is that when we started building these models, we were building models that had 24-bit floating point, very expensive to process. Now there are distilled models that are running 4-bit and 8-bit math, and it's super fast, right? It's basically integer math with fixed decimal point. And that takes, a tenth of the electricity to build a model that's about the same time, and it takes much less time. And it works mostly as well.
But are you still training it?
Yeah, you still train it. So it's the same process, right? So giant hunk of data, you chunk it up, you run it in, you produce the next token, it self-corrects, back propagates zillions of times, but you can do this, much faster now because 4-bit's super fast, 8-bit's only slightly slower. 24-bit is slow. And you're running it on GPUs that are much bigger. And it's getting optimized for that now.
And you're able to optimize because a lot of data is static. So you just say the 4 bits gives you enough.
I mean, you're just building weights in a giant matrix. That's all you're doing. I mean, stacks of matrices, right? But it's all really straightforward. The software itself for training models has become more optimized too. And yeah, I mean, you can train a model on your phone now, which is crazy. That I'm saying those words sounds so weird to me. But you can train something like the GPT-3 on your phone. I train GPT-2 models all the time, and it takes about 10 minutes. And that was state of the art, right? This is so dangerous, we're not going to let it out. So. All right. Well, thank you very much.
Thank you, Dr. Feldman. I'd like to offer this gift to you. It's a token of our appreciation. Whoops, thanks, Eduardo. Thank you for taking the time to come and speak at the Ignite Hub. I know that one of our faculty members referred you to us, so thank you, Stacy. We do appreciate you coming, as I've said before. Our guest speakers come, they are volunteers that come to share their knowledge and information and stories with us, so we're always appreciative that they're able to come. And this guest speaker series is made possible through Verizon. So that's important that I say that. They're our sponsor of this event as well. So, okay. Oh, all right. We have a demonstration. Yes, it's some Ignite Hub swag that we like to give our guest speakers. So thank you again. Oh, before I forget, I want to do well, two things. One, in the chat and coming up on your screen is our survey. I promise you, we look at this. The Hub team was just looking at it, planning for our fall programming. So we pulled the data and we went through and we looked through the themes. And so have identified the kind of speakers that we want to have in the fall. And while you're typing and listening, we have some more programs. Next week starts our Intro to Coding with Swift boot camp, featuring some of our Montgomery King Code instructors. That's 4-day camp that's going to be here. And then we also have Eduardo just finished our IT Career Pathways workshop series yesterday, but there's a lot of demand out there for this. So we're going to bring another series in April. So keep an eye out. Make sure you're on our mailing list. And then, oh my goodness, we're already into April. So I'd like to highlight a little bit of what's coming in April. We have Megan Cooperman, who's our wellness specialist here at Montgomery College, and she's going to talk about wellness for tech professionals. So that's going to be an exciting program. And then our other speakers actually here in the audience today, Camila is going to be talking about her journey as an entrepreneur from healthcare to tech founder. So welcome, glad that you came as well. What else is happening? Oh, and then our monthly career workshop is on April 8th, I believe, and career exploration as well. So the Hub is hopping. Please continue to follow us. If you don't know this, the Hub is on LinkedIn, so you can follow us there. You can also follow us on Eventbrite. You can also follow us on YouTube. We post all of our videos. So we are social, so find us out there and stay in touch. So with that, thank you. And for our in-person guests, we'll escort you across the hall to the community lunch that we provide for our in-person guests. Thank you to Verizon. Thank you, Dr. Feldman.